Follow YouTube and Telegram channel at IELTS Research BD.
Today, we'll delve into the interdisciplinary field of soundscape ecology, a discipline that deciphers the complex relationships between sound and ecosystem health. The concept of a soundscape, defined as the acoustic environment of a given area, was first introduced by Murray Schafer, a famous Canadian composer. Schafer's work in the 1970s revolutionized how we perceive urban and natural environments. He argued that soundscapes are not random noise but layered compositions with inherent meaning, reflecting cultural values and ecological interactions. To systematically study soundscapes, ecologists divide them into three fundamental categories based on their sources. The first category, biophony, encompasses sounds produced by living organisms or creatures. In Australian ecosystems, for example, this includes the croaking of frogs in wetlands during monsoon season. These amphibians use distinct frequency bands to avoid vocal overlap, ensuring their mating calls are heard. The second category, geophony, refers to non-living natural sounds. A striking example is the resonance of rain on the broad leaves of Daintree rainforest flora, a phenomenon so rhythmic that indigenous communities historically used it to predict seasonal changes. Finally, anthrophony captures human-generated sounds, from Sydney's tram networks to agricultural machinery in the Murray-Darling Basin. Unlike biophony and geophony, anthrophony often disrupts natural acoustic patterns, masking critical animal communication. Dr. Bernie Krauser, whose background in music profoundly influenced his ecological research, uncovered several groundbreaking principles in soundscape analysis. Through decades of fieldwork, Krauser demonstrated that every organism contributes a distinctive signature to the acoustic landscape. For example, the harmonics of a lyrebird's mimicry in Tasmania differ measurably from those in New South Wales, allowing researchers to track population health. Furthermore, Krauser's recordings revealed that healthy ecosystems maintain balance in both loudness and frequency. In the Kimberley region, intact ecosystems exhibit acoustic niches. Species avoid overlapping frequencies, much like instruments in an orchestra. Conversely, degraded habitats show chaotic frequency collisions, akin to static interference. Beyond their compositional complexity, soundscapes serve as sensitive indicators of environmental health, offering early warnings of ecological changes. Acoustic monitoring in the Australian Alps detected altered bird migration timings, signaling shifts in climate. Similarly, sudden drops in insect biophony, such as the silence of bees in Western Australian orchards, can warn of invisible pollution, like pesticides. Studies linked these acoustic voids to neonicotinoid pesticides, which impair insect navigation long before chemical traces appear in soil tests. Furthermore, modern research relies heavily on advanced tools like acoustic recorders, which capture vast datasets across diverse habitats. These devices enable scientists to create detailed maps in 3 dimensions. For instance, those of the Great Barrier Reef revealed that fish choruses peak during full moons, synchronizing with spawning cycles. A question often posed in public forums is, which organism dominates nature's soundscape? While sperm whales and howler monkeys are contenders, the champion is a marine invertebrate. The snapping shrimp. Colonies inhabiting Australia's Ningaloo Reef snap their claws at 218 decibels, louder than a gunshot. This cavitation bubble implosion stuns prey and creates microhabitats for other species, proving that even the tiniest organisms can shape entire ecosystems.